Hello everyone. Welcome to the next lecture on the inner product space. Today, one of the most important lecture is Gram Schmidt process. Myself, Dr. Harish Garg, you can follow and subscribe my YouTube channel. Now, what is the objective of this today's lecture? The Gram Schmidt process is a most important topic in the mathematics, especially in the linear algebra and the numerical analysis. What is the objective of this Gram Schmidt process? Suppose you have the vectors v1, v2, fine. Then you can easily check when they can set to be perpendicular. How you can check about the perpendicular? We know the vector v1 dot v2 is 0. Then the two vectors, this is my v1 and v2, are perpendicular. But what will happen if you have more than two vectors, let's say v of n? How you can check about the perpendicular of nature of these vector? And that process, how you can check about the perpendicular natures, that is a basic aim to define the Gram-Schmidt algorithms, or called as the Gram-Schmidt process. The Gram-Schmidt process is a way to find the set of the vectors which are perpendicular to each other. But make sure, students, whenever you have more than two vectors, then the concept of the perpendicular is known as orthogonal vector. Now the concept, or now the question arises is, what do you mean by orthogonal vector? And if you already watched my previous lectures available under the playlist Numerical Linear Algebra, you can see I had defined the concept of the orthogonal and the orthonormal basis. What is the concept is, if you have the set of the vectors v1, v2 and vn, these set of the vectors are said to be orthogonal if the dot product of the each pair vi and vj is 0 whenever I is not equal to j. Meaning, you can say the v1 dot v2 must be 0, v1 dot v3 must be 0, and v1 dot vn must be 0. Similarly, v2 dot v3 must be 0, v2 dot v4 must be 0, and so on. Fine. Whenever these properties are whole, then you can say these vectors are said to be orthogonal. On the other hand, these vectors are said to be orthonormal. The vi vectors are said to be orthonormal if they satisfy the two basic properties. The first one is vi dot vj is 0 for all I is not equal to j, and second is norm of each vi must be 1. Fine. Or you can say the orthonormal means, that is orthogonal, because the first property suggested you the orthogonal, plus the second property suggested you the unit norm. Fine. So whenever any set of the vectors is said to be orthogonal and the unit norm, then we can say it's an orthonormal. And that is the backbone of the Gram-Schmidt process. For example, how you can construct the orthonormal vector? You can see the orthonormal vector. That is the most important challenges in the Gram-Schmidt process or in the linear algebra. So we will discuss the two different types. The first type is when the vectors are my orthogonal, and second is when the vectors are my not orthogonal. When the vectors are my orthogonal, that means your target, that means this property is already satisfied, then your target is to construct only as the unit norm or unit vector. How find how you can define that? If you have the orthogonal vector, say v1, v2 and vn, if I divided its individual norm, then clearly say these are my unit vectors, fine, or unit norm, then you can say this set of the vector is said to be orthogonal vector. Fine. On the other hand, when the vectors are not orthogonal, then you can never apply this divided by norm. Then we can apply the Gram-Schmidt process to construct the orthonormal vector. Clear हो गया इतना? Once your vectors are orthogonal, then we can divide its norm to construct the orthonormal vectors. And whenever the vectors are not orthogonal, then we can apply the Gram-Schmidt process to construct the orthonormal vectors. For example, if I say the v1 and v2 are my two vectors, then we can check firstly the v1 dot v2. It will be 2 plus 0 minus 2, which is equal to 0. What does it mean? Therefore, v1 and v2 are orthogonal vector. Fine. So once they are my orthogonal vector, how you can construct the orthonormal? We can divide it by its norm. So 1 minus 1, 2 divided by, what is the norm is? 1. The square of the quantity is 1 plus 4. Similarly, V2 is my 2, 0 minus 1 divided by 4 plus 0 plus 1. Fine. So I can say this number is 1 by root 6 minus 1 by root 6, 2 over root 6, comma. Second vector is 2 divided by root 5, 0 divided by root 5, minus 1 divided by root 5 are the set of the orthonormal vectors. On the other hand, if you consider another example, let's say v1 and v2, then clearly say the v1 dot v2, it will be 2 minus 1 minus of 2, which is my minus 1, not 0. Once they are not 0, what does it mean? That means v1 and v2 are not orthogonal. Once they are not orthogonal, that means you can never return the orthonormal vectors in the form of v1 dot v2. You can never write that. And once you are unable to write that, then we can apply the Gram Schmidt procedure to construct the orthonormal vectors. Is it clear? Why there is a need of the Gram Schmidt process is clear? Great. Now, what is the principle of the Gram Schmidt process? Fine. So remember, students, you have a set of the vectors. Your basic purpose is to construct the orthonormal vectors. Fine. This is your target. But how you can construct the orthonormal vectors? If I say if I able to construct the orthonormal vectors, fine. Let's say if you construct the orthonormal vectors, then can you define the orthonormal vector easily? Yes, of course, because once you know the orthogonal vectors, then we can define the orthonormal vectors by using this procedure. So that means my target is to construct the orthogonal vectors from the given set of the vectors. Fine. Once we construct the orthogonal vectors, then I can utilize the previous definitions of the orthonormal definition. I can divide it by its norm and then construct the orthonormal vectors. So my target is to construct the orthogonal vectors from the given set of the vector. And that's the basic principle or the target of the Gram Schmidt process. Our target is to construct the orthogonal vectors. Once we can construct the orthogonal vectors, then we can easily convert it into the orthonormal vector. But make sure, students, as I mentioned in the previous example, if the vectors are not orthonormal or if the vectors are not orthogonal, then you can never convert it into the orthonormal vectors. Again, if they are not orthonormal, then your target is to construct the orthonormal firstly and then convert it into the orthonormal. But how you can construct the orthogonal? By using the Gram Schmidt process. Is it okay? Fine, yahan tak bhi? Fine. I hope you can like and comment on the video as well. If you are really interested to learn, you can like and comment on the video as well. Now, what is the principle? How the Gram Schmidt process will work? Fine. That's a very simple concept. The basic principle, the role or the fundamental of the Gram Schmidt process is to construct the orthonormal basis. Fine. But how we can construct the orthonormal? Again, as I tell you, we can firstly construct the orthogonal vectors and then convert it into the orthonormal. And by using some inner product space. Fine. But what is the inner product space? As I defined you in the previous lectures as well. The inner product space is generally is a vector space. Fine. Basically, it is my vector space defined by the inner product. Fine. Like say R of n is my vector space, but we are using some standard inner products. Standard inner products are like R of n, complex numbers, fine, say matrices, M of n of the real matrices, or continuously differentiable functions C of AB. C of AB is a continuously differentiable function like A integration of A to B fx. Find R of n. If you have the two vector x and y, then the inner product is defined like dot product of them xi yi. On the complex plane, instead of the yi, we can define as the complex conjugates. Fine. In the subspace of the continuously differentiable functions, the inner product f comma g is defined as integration from a to b fx into gx. While in the case of the vector space matrices, we can define the inner product is trace of the A star B. Fine. If your matrices are real, fine, then its A star becomes A transpose B. Clear? Now let's start with this Gram Schmidt process. What is the principle of the Gram Schmidt process? You consider, let's say this is my R of n. Fine. Then what is the dimension of the Rn? Dimension of the Rn is my n. That means you have n vectors. Let's say u1, u2 up to un. Out of these un vectors, you find the number of the Li vectors. Fine. You can find the number of the Li vectors. So let's assume the Li vectors are a1, a2 up to ak. What is the value of k? K may be less than of n or is equal to n. Fine. Your first target is to find the number of the Li vectors from the given vector space. Once you can find the Li vectors like a1, a2 and ak, they are finite and linearly independent, then we can construct the vectors v1, v2, vk, which are my orthogonal vectors. Fine. And once we can construct the orthogonal, then we can convert this into orthonormal. And that's the principle of the Gram Schmidt process. But make sure you have to construct the orthogonal set E1, E2 or EK, or you can call as the V1, V2, VK, such that you have to construct the vectors in such a way such that the span of the given set of the vectors a1 to ak and the span of the obtained vectors e1, e2 and ek must be same. And you all know what is the span is. Span means they have defined as a basis plus li. Fine. So you can watch about the linear algebra, my playlist. That's complete lecture on the span of the vectors mentioned, such that the span of the AIs and the span of the EI must be same. Now, the most important concept used in the Gram Schmidt process is the projection. What is the meaning of the projections? I define you with the help of the two vectors. For example, what is the meaning of the projection? In the layman language, projection is my shadow. Fine. Projection is basically the shadow. Let us consider two vectors u and v. Let's say this is my u and this is my v, which make an angle, let's say theta. Fine. This is a projection diagram. Then can you find the shadow? So if I find the projection of v on the u, what does the meaning? Projection means shadow. That means your target is to find the shadow of the v on the u. So if you draw the perpendicular of the vector v, this is my perpendicular. Fine. So then can you find this length? Can you find this vector? What is this vector? So clearly say this vector is my norm of v because it has angle theta. So I can define this number is my cos of theta because it's a base. Find norm of v cos theta. And if you write in the terms of the vector, then you can write as a unit vector in the direction of the u. Is it fine? Now clearly say this is my projection v cos u cap. This is called as the projection. This is called as the projection of v on u, and we can denote it, this number is proj is the projections of the v on the u. Projection of the I can write like this way, is a projection of the v on the u. Fine. Now if you little bit simplify, how you can write that? It's a norm of v cos of theta. What is the unit vector is? I can write as a u divided by norm of u. Fine. Because the length of the norm is non-zero, I can multiply norm of v again, norm of u. Fine. Into u divided by norm of u square. Now you can see the numerator part becomes, what is the a dot b? If you write in the vector form, it's a ab, length of a, length of b, cos theta, which is similar to, fine. Now the other norm, I can define this quantity in the terms of inner product divided by norm of u square, and norm of u I can also define in terms of inner product, that is a u comma u, and that definition is called as projections. That definition which I defined is called as projection of the v on the u. So projection of the v, the definition is projection of the v on the non-zero vector is v on the u divided by on vectors, where the this angle define the inner product between u and v, and that is the backbone of the Gram Schmidt process. So now, or in other word, you can say, because this is my perpendicular, so the projection of v is the orthogonal projections of the vector v on the vector u. Remember students, what will happen if your u will be 0? That means there is no line. So if there is no line or there is no vector, then what is the projection of the v on the u? It is considered as the 0 vector. Now, how you can define the procedure of the Gram Schmidt process? Remember students, मैं फिर एक बार कह रहा हूं, you have the given set of the vectors v, fine, or instead of the vn, you have the given set of the independent, linearly independent vectors ak. Your target is to construct the orthogonal vectors. Fine. Once you can construct the orthogonal, then we can convert it into the orthonormal. Is it okay? How you can construct the orthonormal? We can use the concept of the projection. Fine. And how we can construct the orthonormal from the orthogonal? We can divide it by its norm. Is it okay? And that's the procedure of the Gram Schmidt process. So let's start with this. If you have the matrix A, which consists of, if you have matrix A, which is m cross n, that means how many columns are there? You have n columns. Is it okay? You have the n columns. Out of these n columns, how many linearly independent vectors? Assume that they are k. That means a1, a2 and ak are my linearly independent vectors. Fine. So I can write the columns of the matrix A as a1, a2 and ak. Now, our target is to construct the orthogonal vectors. So by the Gram Schmidt process, we can target to construct the orthogonals with the u1, u2 and uk. Now the answer is, what is the value of the u1, what is the u2 and what is my uk? And once we can construct the orthogonal, we convert into the orthonormal. Now how you can define that orthogonal vectors? The first vector is the same, that is a a1, u1 is first vector is same. Now you have to choose u2 in such a way, such that u2 and u1 are my orthogonal. Fine. What is the meaning of the orthogonal is u2 dot u1 must be 0. Fine. So I can define, second vector is u2. I can find the projection of the vector a2 on the u1. Fine. Later on we will see whether this property hold or not. We will check whether this is hold or not. So a2 minus projection of the a2 on the u1. Similarly, for the a3, now you have the two vectors. My target is to find projection of the a3 on u1 and projection of the a3 on u2, because we have constructed the u2 vectors. So once you had construct the u3, you have to construct the u3 in such a way that u3 is orthogonal to, this is orthogonal to u1 and u2. That means u1 dot u3 must be 0 and u2 dot u3 must be 0. So that's why we constructed the projection of a3 on u1 and u2. Similarly, we can define for the uk, you can define the uk is ak minus projection of the vector ak on u1 minus projection of the vector ak on u2 and so on, projection of the vector ak on uk minus 1, because we have ak minus 1 vectors. Clear? Now I can substitute the values. What is the projection? How you can write the projection of a2 on u1 divided by on u1. Fine. This is u1. Similarly, I can substitute the projection of a3 on the u1. How you can write the projection of a3 on u1? That means projection of a3 on u1 divided by on u1 into u1. Similarly, you can write the projection of a3 on u2 and so on. Based on these UIs are known as, or you can see this is the set of the vectors u1, u2 and uk. These set of the vectors are known as orthogonal vectors. Now, since we constructed the orthogonal vectors, then we can convert it into the orthonormal by using divided by its individual norm. And that's a simple procedure of the Gram Schmidt process. Fine. Now, the only thing which is left behind is to check whether the given set of the vectors we have created are orthogonal or not. Is it okay? Now let's start with this. How you can prove that? Your target is to prove. So firstly, I can check for the two vectors u1 and u2. Now let's start with the u1 comma u2. Fine. I can substitute the value of the u1. u1 is my a1 and u2 is my a2 minus a2 and c. Is it okay? Now you can open this property. What is the norm? What is the norm of property? Like if I say this is the x, y plus z, it will be x comma y, x and y and x and z. Fine. And second is if you have x comma ay, then it is a x comma y. But if a is my real, if a is my real, then we all know complex conjugate of the a is my a. So how you can write that? It is u1 comma a2. Fine. Now since norm, this is the inner product which is a real number, norm is also the real number, so I can write a2 u1 divided by norm of u1 square is outside, hence the remaining is u1 and u1. Fine. Now what is the u1 and u1? That is a norm. So this is and this number is cancelled, and clearly say u1 comma a2, and because this is a symmetric, inner product is always a symmetric, so clearly say this number is my 0. And what does the meaning? u1 and u2 are orthogonal vectors. Now let's start with the three vectors u1, u2, u3. So your target is to prove u1, u2 is 0. Your target is to prove u1 and u3 0. And your target is to prove u2 and u3 0. These are your targets. If you prove these three equations, then it means the three vectors are orthogonal. This we already proved. u1 and u2 are my 0. Fine. Then I can start with the u1, u3. I can substitute the value of the u3. Then it's a u1 comma a3 minus. Fine. Now we can again open this. The first one is u1 and a3. u1 comma a3 minus second value a3 u1 divided by norm of u1 square and u1 and u1 and u1 minus next one a3 u2 divided by norm of u2 square into u1 u2. Fine. Make sure students, whenever you can write as a u1 square, that implies norm of that's the inner product of u1 and u2. Now clearly say what is the value of the u1 and u2? By using the previous property is a 0. So that complete number is my 0. u1 norm square is basically the u1 and u1. So u1 and u1 will be cancelled. And because the inner product is my symmetric, I can write a3 minus u1 is a3 comma u1 is u1 comma a3, and clearly say this number is my 0. Fine. Now last one we will check u2 comma u3. I can substitute the value of the u2. I can substitute the value of u3, or otherwise we can substitute only for the u3. Let's open this. It is u2 comma a3 minus a3 comma u1 divided by norm of u1 square into u2 u1 minus a3 u2 divided by norm of u2 into u2 and u2. Fine. Now clearly say u1 and u2 are my 0. So that part is my 0. u2 comma u2 is my norm of, so that number will be cancelled out. So the only expression which you left is u2 and u3 minus a3 u2. Because the inner product is symmetric, that number is my 0 as well. Therefore, u1, u2, u3 are my orthogonal vectors. Now, in general, how you can prove that? I can assume, because in this case u1, u2, u3 are orthogonals, so in general I can assume ui up to the ui up to the k minus 1s are my 0, and we can start with the ui and uk. Again you can open this bracket. What will happen? It's a ui ak minus this number will be outside. Fine. Now you can see, because ui and uk minus 1 is my 0 for all I lies between 1 to k minus 1. That means whenever I is not equal to k, the number is 0. So clearly say whenever I is not equal to k, this number will be 0. Fine. Last number will be 0. The only number left behind is whenever I is equal to k. Fine. So that means ui ak ये कैंसिल हो जाएगा, then it will be ak comma ui, so that is again 0. Hence the given formulated ui's are my orthogonal vectors. And now since once they are orthogonal, then you can easily convert it into the orthonormal. Now let's start with the one numerical example so that you can easily understand it. What is a vector space? R3. What is the dimension of the R3 is 3. So you have the three different kind of the dimensions. Fine. Out of these three dimensions, they consider the basis 2. कोई दो दे रखे हैं आपको, तीसरा आपको पता नहीं क्या है. Fine. So we will see firstly whether they are Li or not, because whenever you want to apply the Gram Schmidt process, your target is to firstly write the Li vectors. Fine. So let's start with this A1. A1 is 1, 1, 0. A2 is 2, 1, 1. So can you write A2 as any linear combination of A1? No, because you can see it's a twice. If I multiply this number by 2, then clearly say it's a 2, but it is not a 1. So that means there does not exist any real k such that can be A2 can be written as k times A1, or A1 is k times A2. Is it okay? So now that means the given vectors A1 and A2 are my linearly independent. And once they are linearly independent, yes, we can apply the Gram Schmidt process. Fine. Now you have the A1 and A2. So again, देखिए मुझे जल्दबाजी नहीं करनी किसी भी पढ़ाते वक्त ना. तो A1 and A2. So our target is to construct the orthogonal vectors U1 and U2, which are called as orthogonal. Fine. And based on this orthogonal, we will construct the V1 and V2 called as orthonormal. Fine. और कैसे करेंगे, इसके ऊपर हम लगाएंगे ग्राम स्मिथ प्रोसेस. फाइन. और यहां पे इसको इसमें कैसे कन्वर्ट करेंगे, डिवाइडेड बाय नॉर्म ऑफ यू आइस. Clear? So what is the Gram Schmidt process? Your target is to construct the two U1 and U2. So what is the U1 is first number, and U2 is projection of A2 on U1. And how you can write the projection of A2 on U1 is A2 on U1. So let's start substitute the value. What is the U1? U1 is my A1, which is 1, 1, 0. Now U2, I can substitute the value of the A2, 2, 1, 1 minus norm. What is the A2, comma U1? So what is the Euclidean inner product? What is the meaning of the Euclidean inner product is x comma y is basically my summation of xi yi. So that means the dot product. So A2 and U1, this is my A2. Fine. This is my A1. So what is the product is? Instead of writing as a, so it will be the first element 2 into 1 plus second element into first plus 1 into 0. So that will be 2. So that number is my 2 divided by norm of U1 square. Norm of U1 square means that is a U1 U1. So U1 means that is 1 into 1 plus 1 into 1 plus 0 into 0. Or you can also say norm of U1 square is individual number square. 1 square, second number plus third number square. So that number is also 2, comma, what is the U1? 1, 1, 0. Fine. So after the calculation, what will happen? You will get, is it a 3? So can you calculate again A2 and U1? What is the A2 and U1? It's a 2 plus 1 plus 0. That's 3. Sorry. That number is my 3. Fine. That's a calculation. You can do it by own. So that number is my 3. Now you can do it. How you can calculate this number is, the first number is 2 minus 3 by 2, comma 1 minus 3 by 2, 1 minus 0. So that is 4 minus 3 is a half, is a minus half, and it's 1. So half, 1 minus 1, minus half and 1 are my u1 and u2. And clearly you can easily see that. You can easily see u1 dot u2. What is a u1 dot u2? 1 into half, 1 into minus half, 0 into 1. Clearly say these are my 0, and 0 is defined as the orthogonal vector. And once you have proved that it's orthogonal, then you can easily write the orthonormal divided by its norm. So can you find the norm of u1? Norm of u1 is root of u1, that is the element square, 1 square plus 1 square plus 0, which is root 2. Norm of u2, fine, it's a 1 over 4 plus 1 over 4 plus 1. So that number will be 4 is LCM. So 6 by 4, that is root 3 over 2. I can substitute the numbers 1, 1, 0 divided by root 2. So that will be 1 by root 2, 1 by root 2 and 0. And for this case, it is half minus half 1 divided by root 3 over 2. So if you solve them, you can see it's a 2 over root 3 minus 2 over root 3 and it's a plus, sorry, uh, it's not a root 3, it's a root 6. Fine, ऐसे ही बनेगा ना 1 over 2 and root 2 by 3. So that will be 1 by root 6. Similarly for the second part, it's a minus 1 by root 6 and this is 0 are the required answer of the problem. Fine. And you can easily check that the given set of the vectors a1 and a2, span of the a1 and a2 are same as the span of the e1 and e2, which is the orthonormal vectors. So I hope you have enjoyed this Gram Schmidt process. I have discussed only the one example in this lecture, but don't worry, I will explain you the 15 plus examples in our next lectures. Till then, you can simply like and comment on this video. You can share this video with your friends. Happy learning always. Best of luck, students. Thanks for the watch.